Okay, have we gone through 2.1 and 2.2 videos? Right. So let me go through this all in brief, and after that you can go and watch the videos. So remember in chapter 1 we already studied finding limit, right? We are good with finding limits of any problem, right? Like this. If you are given a function and we don't know how to you know find the limit of any given function for the given value, right? So now we are going to use that, the limit technique, to find out the differentiation. Okay. Let's look at a couple of definitions. The derivative and the tangent line. Remember, in your high school, you might have studied, about the secant line. Suppose if you are given a curve, if you have 2 points, the curve, right? If you connect those 2 points by a straight line, this line is called by secant line, right? Okay. So if you know basically 2 points, say this is x1, y1, say this is x2, y2, then we know how to find the slope of this secant line, right? The slope of the line, remember we have formula is given, the slope m is given by y2 minus y1 over x2 minus x1. So we are familiar with this formula, right? So in this particular example, my line is a secant line. So the slope of the secant line is simply given by y2 minus y1 over x2 minus x1. So if you look at the picture here given, right? If you look at the picture here, look at that picture. When you move, one point, say I'm moving this point towards towards another point, right? Then my secant line keep on moving, right? Right? So if this point is somewhere here, my secant line is now here. And if my point is here, then my secant line is this line. So like that, you could move your one point towards another point. So if both the points are meeting at one common point, such condition you will get the tangent line, touching line. Okay, so tangent line is nothing but a limiting line of a secant line. Okay, so when you move one point towards the another, then at the end you will get the tangent line. Okay, so whatever I explain here, you could think of applying here as well. So if the blue color line is my secant line, right? Suppose you are given 2 points now. This is one point, that is x coordinate is c and the y coordinate is f of c. Here my function is fx, right? So this is my y function fx. So if you plug in, here c, you will get f of c. That is the y value of this point, which is y coordinate f of c. Okay, so this is x and this is y. So this is one point. So suppose if you have another point, right? Suppose if you have another point with the increment of delta x with the original value c. Okay. So if you have small increments along the x-axis, then you get the another point. Say that point coordinate is now, you see here, which is c plus delta x. Okay. So for this particular x value, my y coordinate is again c f of c plus delta x, right? Simply you could think of this is like x1, y1 2 points, and this is x2 and the y2, right? So 2 points. So how do you find the slope? Like earlier I said, simply y2 minus y1 over x2 minus x1. So this is our y2 according to my assumption. This is y1, right? So this is going to be x2 minus x1. Why it is? Because my x2 is now c plus delta x. My x1 is simply the starting point c. Then when you subtract these two, you will get x2 minus x1 as c plus delta x, subtract c. So c cancelling, therefore x2 minus x1 is simply delta x. That is why we have here delta x. Okay, so this is the slope of the secant line. Now, as I said earlier, so if you want to find the definition of the tangent line slope, simply move that small increment delta x towards 0. If this delta x, if this increment is closing to the 0, that means that this point ultimately approaching to the original point. Okay, so that means basically we are finding the tangent line slope. So the tangent line slope of the given function, right? So now the tangent line slope of the given function at the particular point C is simply given by this formula. Okay, keep in mind this. So the tangent line slope of the tangent line, I'm writing like this. Slope of the tangent line of the curve fx at the given point, say x is c and say y is f of c. Okay, so if you know the given point c comma f of c, and slope of the tangent line of fx at the given point c comma f of c is simply written as the slope we use m. Okay, that is simply limit delta x goes to 0 of f of c plus delta x minus f of c over delta x. So you have to use this formula to find the slope of the tangent line at the particular given point. Okay, this is the slope, right? So everything is here explained geometrically. Now look at this example. Use the above definition to find the slope of this particular, the given function fx is 2x minus 1 at the given point, 2. Basically, they are asking us to find the slope of the tangent, okay, at the given point C. So simply use the formula. The slope m is given by, formula says that limit delta x goes to 0, f of c plus delta x, subtract f of c over delta x, right? Where c is a given point, x coordinate of the given point. So I know x coordinate of the given point, right? So x coordinate is 2, that is my c. Okay, so this is c. Then let's see who is telling then what is f of c. How do you find f of c?
Plug in 2 for x.
Exactly. In this particular problem, c is 2. So take a function, simply plugging 2 there. Function is given now, 2x minus 1. Right? So c is now 2. Therefore, we need to find out f of 2. Right? You know fx is given. So simply plugging 2 there, you will get f of 2, which is 2 times 2 minus 1. That is 3. Okay? So f of c is 3. C is 2. Now use this formula. That's it. So the slope formula says that is limit delta x goes to 0, limits. Okay, now take f function and plug in the values. Now c is 2 here, therefore you need to find 2 plus delta x. Subtract f of 2 over delta x. Now our task is to find this limit value. Okay, so now I need more space, so let me write down here. So this is going to be limit delta x goes to 0. How do you find f of 2 plus delta x? Simply take fx function and plug in, 2 plus delta x for x. So fx function is 2 times. In place of x, now replaced by 2 plus delta x. Then subtract 1. So this is my, fx function. In place of x, I am replacing by 2 plus delta x to find f of 2 plus delta x. Then subtract f of 2. F of 2 just now we found, that is 3. Then divide everything by delta x. Now only thing is you need to simplify this numerator. That is going to be limit delta x goes to 0. Simply distribute inside 2 times 2, which is 4, plus 2 times delta x, which is 2 delta x. Then subtract the outside of the parentheses. I have -1, -3, which is -4. It's all over delta x. Now this 4 and the -4 gone, right? So you will get limit delta x goes to 0 of 2 delta x over delta x. Now I could cancel delta x. So simply limit delta x goes to 0 of 2. 2 is just a constant value, so therefore that is simply that constant. Therefore, the slope of the given function 2x minus 1 at the given point 2 is simply 2. Slope also 2. So what I want you to understand is, this step, right? So if you want to find the slope by using the definition, use this definition, okay? You have to find the limit value of f of c plus delta x minus f of c over delta x. Read the problem carefully, identify c, then find f of c. These are the two things you have to figure out. After that, find f of c plus delta x. You will be given fx function, simply plugging c plus delta x into that function for x. Okay? So that is finding slope of the tangent line, right? At the given point c, comma f of c. Now let's move to the second definition. Now this is the definition of the derivative of a function. The derivative of function f at given point x is written by like this. So this is read as you have to, if you see like this, you have to read f prime. Okay, so this notation stands for a prime. Prime means nothing but the derivative of function f. So f prime x means the derivative of function f at the given point x. Okay. The definition says that the derivative of the function of f at the given point x is simply f prime x, which is equals to limit delta x goes to 0 of f of x plus delta x minus f of x over delta x. So this formula, this formula is very much similar to the previous, right? The previous formula, you see, very much similar. Only difference is in place of c, now we replace x. Then you will get exactly the same formula here, right? So that means this formula is kind of a generalization of the previous formula. Previous formula will give you only one answer, slope at the particular point c. This formula is kind of a general formula, so you could find the slope at any point x. If you change x, your point slope also will going to change. Okay, so this is kind of the general formula finding derivatives. Okay, remember fx will be a function in terms of x, right? If the original fx function is the terms of x, then f prime x also a function of x. Okay, so that is there. Now I have included two properties of derivatives. The geometric interpretation of the derivative at the given point c, that is nothing but the slope of the tangent at the given point c. Okay, so if you see this notation hereafter, what does mean by that? That means this is simply the slope of, right, a tangent of what? Of the given function fx at the given point x. Okay, so this is the simple notation we use for the slope of fx at the given point x. Don't forget hereafter. So derivative means nothing but slope. Okay. Now there are a couple of ways to express the derivatives. The basic, the most common notation is f prime x. Okay, if the function y is given by fx, so the derivative of f could be written as like f prime x, or some books use this one, dy over dx. Okay, that means you are taking the derivative of the function y with respect to x. Or some books use y prime instead of f prime. Or some books use d over dx of fx, or you could use dxy. But in most common, we could use these three. Okay, f prime x, or dy over dx, or y prime. You could use either notation to write down the derivative of function y is equals fx. Okay, it's up to you. Now use that definition. Which definition? The definition of the derivative of f at the given point x. Remember the formula. Let me write down one more time. That is f of x plus delta x, subtract f of x, then divide by delta x. So this is the formula now we are going to use to find the derivative of given function. So this example, the given function is x squared plus 2x plus 1. Okay, now we use this function and find the derivative. Use the above definition to find the derivative of the given function fx. What do they mean? They mean to find f prime x. So this is the one they are asking you to calculate. Okay, simply I am using the formula, the limit formula, right? So you know now fx. So you need to figure out what? You need to figure out, I write it here. This is equals limit delta x goes to 0. So let us find out now f of x plus delta x. Take fx function, simply replace x by x plus delta x. Okay, I'm taking fx function now. First component is x squared. So my x is now x plus delta x squared. Then plus 2x. So 2 times, now x is replaced by x plus delta x. Then negative 1. So what I'm doing, I'm simply finding x plus delta x. How do you find that? Simply take fx function, replace x by x plus delta x. So I'm simply replacing x by x plus delta x. So you will get x plus delta x squared, then this x will be x plus delta x, then subtract 1. So this is basically my f of x plus delta x. That is why I am writing here, okay, that huge expression. Now subtract fx. What is our fx? Fx was my original function. So write down that. So don't forget to put the parentheses. Okay, this all over delta x. Let me write down one more time. This is f of x plus delta x, including this. Okay, this is f of x. No confusion. Okay. Now you need to use some algebra to simplify this big expression. First of all, you need to expand this quadratic, right? Quadratic expression, right? So what is x plus delta x whole thing squared? You need to expand. Remember, this is nothing but x plus delta x. You are multiplying itself. That is the meaning of square, right? So now you need to distribute x times x is x squared, x times delta x is x times delta x. Then distribute delta x with x. Again, you will get one more time x times delta x. Then delta x times delta x will be delta x squared. Okay. Now, if you simplify this, you will get x squared plus x delta x plus x delta x will be 2x delta x, then plus delta x squared. So, if you expand x plus delta x squared, that is simply x squared plus 2x delta x plus delta x squared. Remember, in high school, you might have studied expansion of a plus b squared. That is a squared plus 2ab plus b squared. Do you remember this? Say yes or no.
Yes.
Yeah, I'm using simply that formula. So my x is now a and my delta x is b. Okay, so if you use that formula, you will come across with this. That is the expansion I wanted here. Let us go and put back. That is x squared plus 2x delta x plus delta x squared. This is the answer I will get for the first square. Then you need to distribute 2 with x plus delta x, which is 2x plus 2 delta x. Then subtract outside 1. Okay. Then you need to distribute with a negative sign for all three, which is negative x squared, negative 2x, and negative to negative positive 1, right? This all over delta x. Now, so many terms in the numerator are going to be cancelled. What are the terms going to be cancelled? Could you tell me?
X squared,
X squared will cancel with negative x squared. Then
2x,
2x, very good, with a negative 2x.
and 1.
1, very good. These all going to be cancelled. So the leftover components are going to be simply 2x delta x left over. Then I have plus delta x squared left over. Then the third piece is going to be plus 2 delta x. That makes sense? It's all over delta x. Now remember, you could simplify further in the numerator. You could pull delta x as a common factor. You can factor delta x and you could put that out of parentheses. So inside I could write 2x plus delta x plus 2. I'm simply pulling one delta x everywhere, okay? So that means here you will have inside the parentheses, here you have one more delta x. Now you are dividing this all by delta x. When you multiply, so these two cancel. Okay? That means you will come up with limit delta x goes to 0, 2x plus delta x plus 2. Now tell me what is the answer. When delta x goes to 0, what you will get?
2x plus 2.
2x plus 2. Very good. So this is basically the derivative answer, f prime x. Remember, the given function was what? The given function was x squared plus 2x minus 1. Okay, so if this is fx, then what is f prime x? Answer we got 2x plus 2. Okay, so these all like using the definition of the derivative. So keep in mind this limit definition. The limit definition of f prime is given by limit delta x goes to fx plus delta x minus fx over delta x. That makes sense? You have a lot more work, right, to simplify and to find the final answer. So final answer is nothing but a function of x, right? You see here, because my original function also, in terms of x. That's why you got f prime also in terms of x, right? Now this will tell you, my derivative function is now kind of generalization, right? Suppose say if you want to find the slope of fx at, say, x is 1. Let's see who is telling. How do you find the slope of fx at x is 1?
Plug 1 into the derivative.
Exactly. Plug 1 into derivative. Remember, slope of fx means nothing but the derivative of fx, which is simply f prime x, right? They are asking us to calculate f prime x at x is 1. So we have the tool now. We have the formula for f prime x, simply plugging 1 over there to find the slope of f at the point 1. So which is f prime 1, that is simply 2 times 1 plus 2. Right? This is multiplied. So that is going to be just 4, right? So you see now very easy once you have the, the slope function. You could find the slope at any point. Okay? Now this is very good exercise for you guys to practice, work on. You are given function x cubed now. Okay? Use the limit definition like just now we did and find f prime x. Okay? So you could practice these kind of problems. Anyway, I'm going to upload the answers for all the class notes maybe later this week. But before that, I just want you to, try, get the answer. Do you have any questions so far? You have no more work, right? So you are learning a lot of new things in Cal 1. So please utilize the time and you have to practice a lot. Okay? So now there is alternate formula to find the slope at the given point C. Remember earlier we had the formula for, finding the limit of the particular point C, which is a limit. Remember that formula at the very first we had f of C plus delta x minus f of C over delta x. This was the first formula we learned today, right? Finding the slope of the given function f at the point C. But there's alternate formula to find f prime C. This is very, very compact and the easiest formula to use. The another version of finding slope at the given point C is simply find the limit x goes to C of f of x subtract f of C over x minus C. Okay, this is another way. So this is a very good formula to find the slope of the particular point, right? Suppose if you look at the previous problem, just now we worked, right? Remember this problem, we got the slope at 1, which is 4, right? So if you try to do the same question to this by using this formula, right? I'm asking you again, the given function was the previous function. I'm taking the same example, right? So if you are given a function x squared plus 2x minus 1, I'm asking you, hey, could you find out the slope at the given point 1? Okay. One way is what? One way is like just now we did, finding f prime x first, then plugging 1 into x. Okay, that is one way, finding the slope, like we got now 4, right? But the second method is simply use the alternate version formula, right? So this formula says what? F prime if c is 1, that is simply find the limit when x goes to c. My c is now 1, okay? Then use this formula to find the limits, okay? So this is limit x goes to 1. What is f of x? F of x is x squared plus 2x minus 1, right? Then subtract f of 1. What is f of 1? This is f of x, right? So if you want to find f of 1, simply plug in 1 into this function. Therefore, you will get f of 1 is 1 squared plus 2 times 1 minus 1. This is 1. So 1 squared is 1, 1 plus 2 is 3, 3 minus 1, which is 2. Okay? Therefore, f of 1, the function value at 1 is 2. I need that here. So f of 1 is simply 2. Then divide this by x minus 1. Now if you simplify this, what you will get? Numerator will be x squared plus 2x minus 1 minus 2 is minus 3 over x minus 1. Okay. Now this problem is nothing but, chapter 1 problem, no? Finding the limit of this function. Remember? There are so many techniques we learned in chapter 1, finding limits. Right? The best way is simply plugging x1 into the given problem. So if you're plugging 1 here, you will get the numerator as 1. 1 plus 2 is 3 minus 3. You will get 0 when you plug 1 into x. But what about the denominator? Yes, denominator also getting 0. So this is 0 over 0 form. So you have to use some kind of techniques to find out the limits. Right? One easiest technique was what? Factoring the numerator. Yes, I could factor this. If you factor the quadratic expression x squared plus 2x minus 3, which is going to be x. So if you factor x squared plus 2x minus 3, you will get x plus 3 times x minus 1, right? Then you have denominator x minus 1. Okay, now this x minus 1 and that one will be cancelled. Then when limit x goes to 1, now you get very good number 1 plus 3, which is 4. Therefore, using the second alternate formula, also we got the same answer, right? F prime 1 is 4. But earlier we used the different version of, formula of finding the slope. So, in summary, we have two formulas now finding the derivative of a function at the given point. Okay? Does it make sense?
Yes.
Okay, what about others? Are you getting? William?
Yes.
Yes, if you have any questions, please let me know. Now, there are some, examples I have included here.
Dr. Raj,
Yes, go ahead.
you haven't done an example or gone over or finding the equation of a tangent line yet, have you?
In this exercise, you mean?
Yes, sir.
Okay, do you see any problem finding yeah, we do after completing this these two couple of points. So I think you should just a minute. I'm checking my notes.
Yes, sir.
Yeah, if you want, I could include one problem, finding the tangent line, equation of the tangent line at the particular point, right?
Yes, sir. And the exercises that I did for the homework earlier involved giving me a set equation and a specific line that included a y equals mx plus b kind of setup.
Yes, yes, I
And
understand.
yeah, I didn't know where to go, even start with that one.
Yes, we do one. Just a minute. I am just checking our textbook. Yes, these are the exercise problems for 2.1. So, okay, find the slope of the tangent line to the graph of the function at the given point. This is all about just finding the slope. This is about okay. Who is Douglas? I see. We will find those kind of problems in 2.2.
Yes, sir.
Okay.
Yes, sir.
Oh, yeah, here also there, but this is for basic function. Okay, so if you want, I could try one problem today with this kind of, oh, yeah, finding an equation of tangent line. So you are asking similar problems, right?
Yes, sir. It didn't show, for this one, it had specifically like a y equals mx plus b kind of setup with the ones on the left, and then specifically the functions on the right that it gave you. It didn't give you any coordinates. It gave like the problem that I was talking about from earlier gave me like 2x squared, which may be a parabola. I can't think of it off the top of my head,
Okay.
but I didn't exactly. I looked all up and down the MindTap, like through the pages,
Okay.
and I couldn't even find how to start it.
So you are talking about from web design questions?
Yes, sir.
Okay, so are you talking about 2.1 or some other sections?
I think it may be 2.1. It's the section that was supposed to be done on Monday and Tuesday, and or after the test. And I was going to try and do that today to catch up, and I didn't even know where to start with it.
Oh, I see. Let's do like this. Let me finish today 2.1 and 2.2.
Yes, sir.
And after finishing those two, and if you could you check your problems in particular? Then after explaining, we will go there and web design. We will check that particular problem, whatever you are talking today.
Yes, sir.
Okay. Right. Let me continue first, and okay. So now look at the couple of examples here in these pictures. The first one, f is not differentiable at x is 2. Why it is? If you look at the first picture here, right, the curve is continuous curve. Is, you see, you could draw this entire curve without lifting a hand. That is a continuous function. But if you check the given point here, right, when x is 2, they are telling that function f is not differentiable at x is 2. What does mean by that? Could you explain in words? What does mean by f is not differentiable? What do you mean by that?
Exists.
Limit doesn't exist. That's the meaning, right? If
Yes.
f were differentiable, then you would have got the limit answer, right? You know now differentiable mean what? Differentiable means the function has derivative, right, at that particular point, right? So why we say that the function is not differentiable at 2? Because we cannot find what? F derivative at 2, right? Why can't we find this guy f prime 2? Because if you try to use the definition, so let me clear that. Okay, why we can't find the f prime of 2? Any suggestion? Why we cannot find f prime 2? If you want to find f prime 2, how do you find? Formula says that is limit x goes to 2, right? F of remember c is now 2. This is C according to our formula. So you will put 2 plus delta x, subtract f of 2 over delta x. So this is the definition, right, of my, f prime 2. But if you try to find this limit, remember in chapter 1 we studied, if you have limit answer for the particular problem, you should have same answer for, to the left and to the right of the given point, right? So if you look at x approaching from the left to 2, what is the slope you will get? That is, if you approach 2 from the left, right? Look at the picture. Picture says that if you approach 2 from the left, your line slope is -1, right? But if you approach 2 from the right, from this way, then our slope along the curve is +1. That means what? That means you get 2 different limit answer for left and right, right? There are 2 different answers, but remember in chapter 1 we learned you can't have 2 different answers for existence of the limit problem. So if you cannot find the common value, that means limit is not there, does not exist. That is why in this case we can't find the limits. Therefore, there's no derivative at the point 2, right? So if you see, the curve like a sharp turning, right? Like very sharp, like edges kind of things, then at that point you cannot, you know, differentiate. So you cannot find the, derivative, okay? But if your curve is very smooth, turning very smoothly, then there's a differentiable, you could differentiate there. That is good. But for the sharp turn, there is no, um, derivative. Okay, so that's the meaning. So now the next one, if you look at problem number 2, we already have been given a graph. This graph is for y is equals x to the power 1/3. This graph seems like, very smooth graph, right? No point turning, very good smooth graph. But the thing is, if you check at the origin, when x is 0, right, then there's a problem. If you try to find the slope at this point, the slope is nothing but the tangent line slope, right? So if you try to draw a tangent line means the touching line, to that curve at the origin. That means the tangent line at this point is nothing but y-axis, right? Y-axis is just going through, touching that point. Therefore, the tangent line at x is 0 is nothing but y-axis, right? Then what is the slope of, this guy? Remember, now line is going upwards, right? So if you have vertical line, there's no slope for vertical line. So the slope of vertical lines are always undefined. Okay? So the slope of y-axis actually undefined, it does not exist. That is why we cannot find the limit also, right? Limit means basically the slope, right? So therefore slope is not there, does not exist. That is why it is not differentiable at 0. Okay? So there are 2 cases now you learned. One is if you have a sharp turn, then there's no, differentiability there. And if you have this, vertical tangent line at the given graph, there also you cannot find the derivative. Okay, no, you cannot differentiate. That makes sense?
Yes, sir.
Okay. Now, this is another catch. This is very, very useful theorem. What is that? differentiability implies continuity. If you could differentiate a function, of course, that function should be continuous on that particular open interval. Okay. So if function is very good, if you could find all the limits, that is, differentiable, right? So if the function is, having this differentiability properties, then that should give you always continuous. Okay. But the converse is not true. All the continuous functions are not, differentiable. Okay. This is not true in general. This side is not always true. Only one side is true. Okay. That is what this, the note is there. The converse of this theorem may not be true always, right? All the continuous functions are not differentiable. For example, look at this first one, right? Remember, this function is continuous, right? This function, this graph is continuous, but remember, it is not differentiable at 2. Therefore, continuity does not imply, differentiability. But differentiability will imply always continuity. You see that? Okay, so let me go through 2.2. 2.2 is kind of learning the formulas, right? So you are going to learn a lot of formulas here, right? So these all just finding formulas. So I just want you to go through this, but briefly I'm telling you, you just, write down all the formulas, whatever you are learning in piece of paper, and you can learn all the formulas, right? So, or you see the formula sheet there in your textbook, right? So if you look at your, the textbook, there you will find out the first page is will given all the formulas and all. So you could take a printout of that, or you could just write it down somewhere else, and and use all the formulas. Okay, so you are going to learn a lot of formulas in Cal 1, right? Remember, you could use derivatives means what? Simply differentiation. Okay, same meaning. You could use either f prime or dy over dx or y prime. So you could use any of these three, right? Suppose if I write like that, d over dx of x squared, what is the meaning of this? Could you explain in words? D over dx of x squared means the given function is now x squared, okay? So you are finding the derivative of x squared. That is the meaning, okay? So the meaning of this is nothing but differentiation of what? Of the given function x squared. With respect to what? I am differentiating with respect to the variable here, x. That is the meaning, okay? No confusion, right? In this case, our function y, that is fx, which is given now x squared for this example. All three are similar, y, fx, and x squared. All denote a function of x, which is x squared in this example, okay? Now, if you look at theorem 2.2, how do you read this? The differentiation or the derivative of value c is always 0. What is here c? C is a real number, fixed number, constant number. If you take the derivative of any constant number, constant value, always 0, right? If I ask you, hey, what is the derivative of 10? What do you say? 10 is constant, answer is 0. Any constant, could be any constant, okay? D over dx of, could you tell me what is the derivative of pi?
It's 0. It doesn't change.
Exactly, because pi is constant, right? 3.142, no change, constant, fixed, always 0. So that is what this theorem says. C could be any real number constant. But the second formula is important, right? The derivative of any function in the form of x to the power n. Here n could be any rational number. Do you know the meaning of rational number? What is meant by rational number? Rational number means you could write that number in fraction form, right? Okay, here a, b are integers. If you could write the given number as a fraction a over b, a, b are integers, maybe negative, then these kind of numbers are called the rational numbers, okay? Right? There is another number which is called irrational. Irrational number means what? Numbers you cannot write a over b form. For example, what is square root 2? Can I write square root 2 in a over b form? A and b are integers. No, I cannot write, right? I cannot write this guy a over b such that a and b are integers, because square root cannot be written as a fraction with the numerator and denominator are integers, therefore which is not rational, which is irrational. Okay. So, but in this case, in our, the definition, n should be irrational. Okay, rational. N is rational. So the derivative of x to the power n is always going to be n times x to the power n minus 1. Okay. For example, could you find the derivative of x cubed? Formula says that yes, you could find the derivative of x to the power n. If you compare your problem with the formula, instead of n, now I have 3 here, right? Do you see that? So simply use that formula, simply, plugging 3 for n. So you will get n is now 3, right? If you use this formula, d over dx of x3 is simply n is now 3 times x to the power 3 minus 1. So if you simplify further, you will get 3 times 3 minus 2 is 3 minus 1 is 2. Therefore, the derivative of x cubed is simply 3x squared. Make sense?
Yes, sir.
Okay, remember I asked you one problem earlier in chapter section 2.1. I left one problem as a homework just to try. Remember this problem. Find the derivative of x cubed. Now you know the answer. Same problem. Same problem. The derivative of x cubed. I just took here. What is the answer I got? 3x squared. Right? But I did not use the definition. I simply used the formula, power rule. Right? But now you know the answer. You should get this answer, 3x squared. The derivative of x cubed is 3x squared. But you have to get that answer by using the definition. This is, remember, 2.1, right? Section 2.1 is about the definition of the derivatives. So use the definition and find the f prime x. Answer should be 3x squared. But you have to get that by using, like this we did just now, using the limit definition, okay? Try to use the definition and find the answer of f prime x. You should get 3x squared. But now things are very easy once you study 2.2. You don't need to use the definition always. Remember, using definition is not easy, right? You have a lot of steps. Finding limit of, that function. It is not always going to be easy. Once you have like these theorems, it's very easy. Okay? Theorems are made after, suffering lots. So you simply using the formula. Okay? Simply use the formula. Does it make sense or not?
Quick question about the power rule. In relation to the question that I brought up earlier, like say if you were given a function of 2x squared, would that still fall into this where you could plug it in and the n would
Yes,
be
right,
okay? Okay.
right. You are correct. So now you are going to tell me the answer very quickly. Find the derivative of the following functions. What is the derivative of the first function? That is f prime x. What is your answer?
2.
You have to be very careful.
0.
0. The given function is now 2 pi, which is constant, right?
Yes, sir.
So the derivative of constant is just now we saw always 0. Now what is the derivative of y here? That is y prime. What do you think?
That's also 0 since k is constant, right?
Exactly. Again, the given function y here 3k. They are telling that hey, k is constant, fixed value. So you are multiplying fixed value with another number which is 3. So 3k also going to be a fixed number. Therefore, altogether 3k is a constant fixed number. Therefore, the derivative of constant function again going to be 0. But third one is not constant, right? Because you see the variable x. So to find the derivative of g, which is g prime x, simply use the formula just now we have. Now remember, your function is x to the power 4. Then what is n here?
4x cubed.
Yes, n is 4. Simply plugging 4 into your formula here. So g prime x, right? That is, in another word, you could write d over dx of the given function x to the power 4. That is, formula says that 4x 4 minus 1. N is now 4. Now simplify this. That will be 4x cubed. So that is the
Okay.
derivative. This step, you know, this guy is not mandatory. You don't need to write this. But if you want, you could write, or you could write down directly g prime is 4x cubed. Okay. You could, if you are very much, you know, fluent after doing so many problems, you don't need to write these 2 steps. This is optional. Okay, you could right away write the answer. G prime x is simply 4x cubed. It is understandable. Okay,
Yes, sir.
right. Now look at the last one. Always you need to write the given problem in which form? In x to the power n form. So you have to play around a little bit. Remember, you need to write this guy in terms of exponents. How can I write? Remember, x means nothing but x to the power 1. You need to move the denominator into the numerator. So you studied in high school. When you flip the values into denominator to the numerator, you have to change the power sign, right? Alternate the sign. So if you move x to the power 1 from the denominator to the numerator, it's going to be simply x to the power negative 1. Okay?
Okay.
Yes, that means the given problem 1 over x is nothing but x to the power negative 1. Now you could apply that formula, right? Now this guy is the form of x to the power n. What is n here?
Just -1.
Just negative 1. Just compare these two. In place of n, we have negative 1. Right? That means what? That means now I could find, remember the original problem was y. Therefore, y prime is nothing but d over dx of x to the power negative 1. Now this is my n. If you look at the formula, this is n times x to the power n minus 1. Right? So the first negative 1 coming for the formula n. This is negative 1 itself you have in the formula. Now you need to simplify. Negative 1 times x to the power minus 1 will be minus 2. Okay. So you could leave the answer like that, or if you want, you could move back this exponent negative to the denominator to make the positive. So you could just move negative 2 into the denominator to write the positive 2 for x. Okay, so if you are not that much good at, switching the numbers and all, so my strong suggestion is please go and refer your college algebra, okay, and pre-cal and your high school, whatever you learn mathematics. So please make sure that you have a good foundation, of basic things, okay?
Is the reciprocal answer going to be the one that you're looking for on the test, or could we leave it as the?
For me, okay, either way.
Yes, sir.
But when you do web design assignments, it will ask you to write in particular way, okay?
Yes, sir.
Yeah. Right. Now this is the question you are asking. Finding the equation of the tangent line to the graph of given when 1 point.
Yes, sir. Yes, sir.
Okay. So remember, if you are asked to find the equation of the line, you need to write down, if you know, remember, again, I would say high school. If you are given a point and if you know the slope of the line, so this is the slope of the line, okay? I'm telling you here, you know the slope of the line and 1 point, right? So this line is passing through a point. Then how do you write the equation of the straight line? The equation of the straight line is simply y minus y1 equals slope times x minus x1. You remember this formula you learned?
Yes.
Very vaguely.
Yes. So this is the formula basically now we are going to use to find the tangent line equation. Remember, tangent line also a line, right? Therefore, we are going to use the same procedure, whatever you learned. Remember, if you want to use the the x1 y1 slope form, first of all you need to know the slope of the line, right? Remember, now we have the tool. Slope of the line is simply, now we know, which is the derivative of the function, right? Am I right? So now you know the point. We are looking at the point where x is -1. Basically, this is your x1. Then how do you find y1? If you know one point, x value of the point, simply plugging that x value into the formula will give you always y value, right? Fx means y. So simply if you're plugging x -1 into your function, that will give you corresponding y value. That is my y1. So if x1 is -1, then y1 is going to be simply -1 squared because my function is x squared. So -1 squared is nothing but, 1. So you know x1 and y1, right? So I'm going to use basically the slope formula, tangent formula, y minus y1 is equals m times x minus x1. Right, now what is my task? Your task is to find slope of fx at x -1. Let's see who's telling. What is the symbol we use for this all expression? Simply you could write in, letters. What does mean by that in terms of notation?
X plus delta x.
I just need the notation. I don't want the definition. I just need the notation. Slope of fx is denoted by which notation, which symbol we use?
M.
Okay, m, that is okay, m, but could you connect with a function? Just now we learned slope of function is what? What is the mathematical term we use for the slope of the function f? Okay, what is the things now, just now we learned?
Derivative.
Okay, tell me now. Could you connect the derivative with the slope?
Yes.
What is that? the derivative of function at -1 is nothing but the slope of the function at -1. This is the meaning. This is the meaning, right? The derivative of function at -1. That makes sense?
Yes.
So slope of fx at -1 means f prime at -1. Very short. You see, just one letter we use. That makes sense? That means what? That means your task is to find the derivative of f first, then plugging x -1 there. Okay, now you are going to tell me the given function for this problem is x squared. Now what is f prime x?
2x.
2x. Why it is 2x? Just now we saw we have formula to find the derivative of function. Right? So if the function is x squared, the derivative of x squared, now n is 2. So the derivative of x to the power n is simply n x n minus 1. No confusion. F prime x means d over dx of fx. No confused, okay? So if you simplify that, that is 2 times x to the 1. X to the 1 means simply x. So this is simply 2x. Yeah, it will take a while to learn these things. Once you catch up everything, it will be very, very smooth, okay? Yes, the derivative of the function is now 2x, but I need what? I need f prime at -1. What is that? Simply plugging -1 into your answer. Just now we got f prime x, right? So I'm simply plugging x -1. So that is -2. This is our slope. Now you know slope and you know x1, that is -1. You know y1, that is 1. So now it is easy to write down the formula. Y minus y1 equals m times x minus x1. So I'm using that formula. Y1 is 1. The slope just now we got -2. X minus x1 also -1. So now this will be minus into minus plus 1. Distribute inside. You will get -2x, -2. That is y minus 1. Now move -1 to the another side. So that is y is equal -2x minus 1. So this is the equation of the tangent line at the given point -1 for the function. What is that? X squared. Make sense? So what did you learn today? The slope of the tangent of fx is nothing but the derivative f prime. Okay? Now,
So,
okay, go ahead.
Can you scroll up just a little bit on your screen? After you find and sorry for the questions. I'm just trying to clarify. So d over d at x is the same as saying f prime or y
Yes.
prime.
Yes, y prime, f prime, the function, all same.
Okay, and whenever you find f prime, which would be 2x, you have to substitute it in with -1 because
N is
that's
n is 2 now, right? For this problem. The one
yes,
just,
sir.
yeah. So you have to plug in 2 there. Yes.
And you plug in the -1 for x because that's what's given in the problem for -1 or
Yeah.
for x. Okay.
Yes. After finding the derivative, then you have to plug in -1 to find the particular slope,
Okay.
right?
Yes, sir.
Yeah. Okay. Very good. The next one is, the third formula we have. If you look at the third formula, the derivative of function fx, but there's a constant multiple of that function, right? C could be any constant. So simply you are multiplying, fx function with the constant. So the derivative of that function is simply, you could just, write down the constant as it is and simply find the derivative of function only. They're telling what? Hey, no need to think about the constant. You just focus on only function. Then take the derivative of that function. That makes sense? Now look at this first. The given function was 5x cubed. You see that? So now the constant is 5. Function is x cubed. Okay. What are they telling? They are telling that the derivative of function y is simply, you just move constant in front of the derivative and simply find the derivative of x cubed. Don't worry about 5. You just simply find the derivative of x cubed, then multiply with 5. That's what they are telling, right? That makes sense? So if you want to find the derivative of 5x cubed, you just write down 5. Now find the derivative of simply x cubed. Now we know how to find the derivative of x cubed. N is now 3. So if you look at that formula, now n is 3. So formula says that n times x, n minus 1. Now n is 3, so 3 minus 1. This will give you 5 times 3 is 15. X, 3 minus 1 is 2. So that is why you got the answer 15x squared. Okay? So simply I'm telling, if you have constant multiple of inside the function derivative, simply pull out that constant in front of the derivative. Then you just focus on only the function derivative. Then after getting function derivative answer, simply multiply with that constant. Okay. So second one also the same thing. The constant is 2. So you pull 2 outside and just find the derivative of x to the power minus 1. Yeah. This all just explaining, and why don't you, think about this. Okay. So before going to do that, please watch the videos. Watch the videos first, okay? Then only you will understand. Right? Then watch the videos. Then you can try to complete my class notes. Then after uploading my work, you could compare with your answer. But anyway, this is online class. I don't know how far you guys working. So make sure that you are utilizing the time properly, okay? Even though I'm not monitoring you, I don't know how you guys working. Make sure that, you use a lot of time to practice on Cal 1, okay? That makes sense?
Yes, sir.
About others, who is here? Yeah, I see William. Okay, William, are you okay?
Yes.
Yes. That's it for today. Do you have any questions?
So, the WebAssign that I brought up to you earlier, that section can be completed mainly using these 3 rules.
Right.
Okay. I'll go back and I'll try them again. If I have any
Yeah.
problem, I'll just ask the teacher.
Oh, you have one more thing here. This is the last theorem you have here.
Okay.
Suppose you have 2 functions, but in between 2 functions you have plus or minus sign. That means you could split the differentiation into 2 pieces. That's very, very easy property, right? You could think of sum rule or difference rule, whatever you like. Suppose if you are asked to find the derivative of 2 functions, say x squared plus x cubed, you could think of the first function as your f function and second one as your g function, right? So if you want to find the derivative of the sum, the derivative of sum is nothing but the sum of the derivative. Okay, so this could be written as find the derivative of first function, then add the derivative of second function. Simply you could split the differentiation operator into plus or minus. Does that make sense? So that means you could find the derivative of x squared and derivative of x cubed separately, then add them together. So this is this rule is applicable for negative sign as well.
So is this rule just saying that whenever you find the product of putting so x squared and x cubed, that'd be the or not constant, that'd be the power rule. So once you find both of those values, you could just add or subtract them. Is that all it's saying? Or
Yes, sum rule or difference rule. Yeah, you are correct.
yes, sir. Okay.
Yes, good. Very good.
All right then.
So now, you know, in 2.3, 4 and all is going to be a little bit harder because you are going to learn a lot of new formulas like today. Okay. So I just want everyone to, you know, focus on all the formulas in detail. Okay. So at the same time, please, if you have any questions, let me know. Look at that example. You are asked to find the derivative of this huge expression, right? You could think of, you see now, in between all of the components, you have either plus or minus sign, right? That means you could think of these all separately, like a new problem, and find out the derivative separately, then just add them or subtract according to the sign which are given in the problem.